Hey class, how's it going? I want to talk today about the chain rule. The chain rule is one of those places where I often make my mistakes, and so I wanted to go over a few examples with you to hopefully prevent you from making the same mistakes that I do. Okay, so I'm going to do two examples here. The first one's problem number 18, and then in another video I'll do problem number 58. Okay, so here is problem number 18, where we have a square root involved. And usually if we have a square root involved, for example, y equals x, the square root of x, taking the derivative is no problem. We just convert it to x to the 1/2, and then we do the power rule, where we bring the 1/2 in front, and then it's x to the negative 1/2, because we subtract 1 from the exponent. All right, and that's usually no big deal. But what makes this one more difficult is that underneath the square root is not just x. We have some other function underneath the square root, all right, which means we need to do the chain rule. All right, but let's go with this sort of thinking that we have over here and try to apply it here. So we have y equals 4 times something under a square root. Okay, and that something in this case we're going to call u, and u is secant x plus tangent x. All right, so we're just doing a little bit of substitution so this doesn't look so scary. Okay, so we remember we can write that as 4 times u to the 1/2. And so when we want to take the derivative of it, we want to find y prime. We take this 1/2, put it in front, so 4 times 1/2 is 2, u, and then we subtract 1 from the exponent to get negative 1/2. All right, in this case, up here, we were done. But over here, underneath the square root, is some function u, okay? And when we have some function u, we can't just stop here, we need to chain rule it. So we need to multiply it by the derivative of u. Okay, so let's find that derivative right here. So u prime, the derivative of secant is secant tangent, and the derivative of tangent is secant squared. Alright, so we've got the derivative here, but we have it in terms of u. We want it in terms of x, so we're going to go back and plug everything back in. Alright, so y prime equals 2, u is secant x plus tangent x, and that needs to be raised to the negative 1/2, and then u prime is secant x tangent x plus secant squared x. Alright, so actually we are done taking the derivative. However, because we're good calculus students and we want to push ourselves further, we're going to simplify a little bit. Something that jumps out at me is that both of these terms here have a secant, and if I were to factor out that secant, I'd be left with a tangent plus secant, which is what we have here, and that leads me to believe we'll be able to do some simplifying. So I'm going to do that factoring right now, and then we'll continue with the simplifying. Alright, so here I factor out the secant x, and I'm left with a tangent x plus a secant x. Alright, so I'm just going to do some reordering. Here's my 2, my secant x, and then we have a secant plus tangent to the negative 1/2 and a secant plus tangent to the positive 1. And since we're multiplying by those together, we will add those exponents. So an exponent of negative 1/2 plus an exponent of 1. So we're going to have secant x plus tangent x, and the new exponent on that factor is going to be 1/2. All right, now we're pretty much done, but I'm just going to rewrite it like this. 2 secant x, oops, excuse me, I was rewriting it with the radical sign. Secant x plus tangent x. Alright, so that was a pretty complicated chain rule. There was some trig involved and some radicals, which makes life really tough, but if you see if you're organized, you can handle it. Alright, it takes some time, you need to be patient with it, and you can't look for shortcuts. Alright, if you have any questions, please write them down and bring them to class, and we'll talk about it tomorrow.